I've been continuing work on my open-world action-adventure game, Sacred Forest, in which you play as a pixel art bow-wielding heroine who can swing with grapple arrows, glide with her cape, and even slow time to take out the blight-infected monsters within the diverse forestscape. It's developed in Godot 4, and you can even wishlist it on Steam right now. I'll leave a link down below. It's been a little while, so what's new with the game? Well, you may have noticed the game looks a little different. Something about the colors of the character and world give off a vibe that's not like the previous devlog. Also, the perspective and feel of the camera are slightly changed as well. I used Godot as the game engine for Sacred Forest, and there are quite a lot of ways to tune the look and feel of the game by adjusting the environment and the post-processing, as well as tuning all of the properties of the player camera. Here's a little comparison of what it looked like before, and of course here's what it looks like now. Probably the most noticeable difference comes from adjusting the tone mapper in the environment properties. What's a tone mapper? A tone mapper in Godot is like a magical filter that helps make pictures look good on your screen. It takes really bright and really dark parts of a picture and squishes them into a range that your screen can show, so you can see all the details, like bright clouds and dark shadows, without anything being too bright or too dark. The default tone mapper is set to linear, which just adjusts the dimness of the image so you can see everything on your screen without any special changes to the colors. It's simple and straightforward, like turning down the brightness evenly. I personally like the look of the Ace's tone mapper. This one not only adjusts the brightness, but also makes colors look more natural and cinematic, like in movies. It's like having a professional artist touch up the picture to make it look its best, but at all times. I'm definitely not done tuning this part of the game, and I may even end up writing my own custom tone mapper by the time I finish with everything, but I at least like the direction for these changes. Now about the camera. Making any change to the camera is like changing the eyes of the player, since it directly controls how the player perceives the world. You can essentially control a camera in Godot just like you can in real life by changing things like depth of field, exposure, or even physical attributes like focal length and shutter speed. All of these settings combine to set the visual feeling of the game. For example, you could replicate something like a 35mm movie film camera to give it a really cinematic feeling, or something a little more actiony with a wide-angle lens. Like the tone mapper, I'll probably be tuning this throughout the entire development of the game to get it to feel exactly how I want. Apart from just changing how the game looks, I've also added a ton of new models to the game, things like various trees and foliage and materials to build out structures within the world. In a previous devlog, I talked about using the Spatial Gardener plugin by Dreadpon. It's a super handy tool that lets me paint foliage directly in the game, and it automatically adjusts the level of detail based on where the player camera is. With so many assets in the game, I've had to streamline my workflow to smoothly get everything from Blender into Godot. Keeping things organized and optimized is crucial, especially for an open world. Here's one example. Spatial Gardener lets me create brushes to paint a mesh, a node, or both. To keep the game scalable and reduce draw calls, I separate the colliders from the meshes. Let's say I have a rock object. I split it into two parts, the rock mesh and the rock collider. Both of these go into my rock brush in the Gardener. When I paint the rock in the game, it uses a multi-mesh for the visuals and a separate invisible collider for collisions. This separation means all the visual rocks get grouped into a single draw call, which is great for performance. It's much more efficient than combining the mesh and collider into one node. By doing this, I ensure the game runs smoothly, even with lots of painted objects. Alright, on to something less technical. Because I'm really trying to work towards creating a demo for the game, which needs to include a small tutorial and at least a few things for the player to do in order to get a taste of what the full game will be, there are some characters that need to be made in order for the demo to make sense, so I've been working on some of the animations for those characters. Since Sacred Forest is a 3D game with 2D sprite characters, making the game feel immersive requires some tricks. For characters that never move, it's pretty simple. They just need an idle animation and can always face the player as a billboard sprite. However, for characters that move, it gets tricky. If the sprite always faces the player, the walk animation can look wrong, as if the character is walking in the wrong direction. but turning off the always face player feature makes the character look flat, like a piece of paper from certain angles. Many games with HD pixel art or 2.5D styles avoid this problem by fixing the camera to a specific viewpoint. This way, developers control how characters are seen, preventing them from looking flat. To tackle this in Sacred Forest, I developed a system that changes the character's animation based on the player camera's orientation. For example, this NPC here changes its perspective. When I'm to the side, it shows a side view, but when I'm behind, it shows a back view. This character only has 4 perspectives right now, so it's not super smooth yet, but you get the idea. Alright, I want to talk about flags. Sacred Forest is an open world game, and the world has to change depending on what the player has already done. NPCs need to move around, their dialogue needs to change, whole parts of the world need to look completely different if something huge has already taken place. To control all of this, and also track the progress of the player, I decided to go with a flag system. This is kind of an old school method of tracking progress in a game, but it's simple and it works. A flag is just a Boolean variable that can be true or false. So for everything that I want to track in the world, I need to be able to create a flag for it, and then be able to set the flag to true once it's completed, or false if it's not complete. All the flags act as a really simplified database for the state of the game. To manage all of this, I ended up creating a custom plugin for Godot, which adds a flag section to the engine. I can go in, create new flags, give them descriptions, and then within any script in my game, I can make checks to see if flags are set, and set them whenever I need to in order to control everything in the game. I can also save these out and load them in to make save states. The flag system is pretty simple, but it acts as the foundation for controlling the game. I went ahead and built on top of the flag system for the next custom node, the Conditional Spawner. I can drop one of these conditional spawners into my world and then create a custom condition statement by using flags to check in order to spawn or despawn any of its child nodes. So let's see it in action. Let's create 3 new flags. I'll call it flag 1, flag 2, and flag 3. So back to my spawner. I can add 2 OR flags, flag 1 and flag 2. This condition means the spawner will check if flag 1 is true or flag 2 is true. Right now both flags are set to false, so the condition is not met because false or false equals false. So the spawner would not spawn any of its child nodes into the world. Now if I set flag 1 to true, the condition is met because true or false equals true. So the spawner would spawn in the child nodes. I could add an AND flag as flag 3, so now the condition would check flag 1 or flag 2 and flag 3. So either flag 1 or flag 2 needs to be true and flag 3 needs to be true in order to spawn the child nodes. The last type is the NOT flag, so it checks that the flag is not true. This is a pretty simple little node, but it's extremely powerful for controlling what is happening in the world depending on if flags are set or unset. So I will definitely be using this quite a bit within Sacred Forest in conjunction with my custom zone system that I talked about in a previous devlog. It will especially be helpful for controlling dialogue, which for dialogue, I think I've pretty much decided I'd like to use the Dialogic plugin. I've used Dialogic 1 in the past, and I really liked it, and Dialogic 2 has a lot of great features, and it's really easy to use, it's customizable, and I feel like it's definitely going to satisfy my needs. I've made my own dialogue systems for previous games, but for Sacred Forest, using Dialogic feels like the right move. I won't go too in depth, but essentially you create timelines using the built-in visual editor. Really complicated control flows can be made pretty easily using all the built-in events to do things like display text, get responses, play music, and really just a ton of stuff. You can even customize the plugin to do whatever you need to do, which is pretty cool. Within the game, to trigger the dialogue, you have to call a function which takes in the name of the timeline. So in order to make my characters be able to start their dialogue timelines, I created an interaction system. Essentially, I can add an interaction node and place it somewhere in the world. I'll add it to this NPC character. I can give it some interaction text, so for talking to my NPC, I'll just put talk. So now I can add a dialogue by clicking Call Dialogue, which lets me then choose a timeline from the drop-down menu. So now if I play my game and run up to the NPC, a talk option appears, and if I press the interact button, it plays the dialogue. This interaction system also supports the same flags as the conditional spawner to decide whether the interaction is valid. Apart from dialogic timelines, it can also play animation players for stuff like cutscenes, as well as just call functions on different nodes. So I'll be using this for pretty much every type of interaction, like opening doors, picking up items, and a bunch of other stuff. This system also supports all major controller glyphs, so it should show the correct glyph depending on if you're using a keyboard, Xbox controller, PlayStation controller, or some other type of controller. The GUI display part of the interaction isn't done yet, I just wanted to show that it works, and I'll be making it look better later. Well, that's about it. Let me know what you guys think about the progress on the game. Also, you can join the Discord and check out the Steam page. Or not. Until next time.